So welcome to our poster on open and continuous community benchmarking of bioinformatics tools. So this is the website of the project, and this is the source code. This project is very extensible to different projects and bioinformatic tools, but here we focus on single-cell RNA-seq tools, and I will let you know why in a minute. So also this poster has been group work of these people, and especially Anthony Sunwell has worked a lot with me on this. Yeah, so benchmarking is an important part of the research we do in bioinformatics, but also actually in other fields of areas. And single-cell RNA-seq tools are a very good use case because the field has been exploding in the last years. So there have been developed more than 900 tools, not all for the same task, but often for similar or the same task in the last years. And it gets obvious that we need benchmarking there, so to understand when to use which tools and also to make the most of this variety of tools. And even within the benchmarks, there has been, or even within benchmarking, there has been redundancy. And this is one of the problems. So that although we have benchmarks, they are not coordinated and not reproducible and extensible. So every researcher that develops a new method basically needs to do his or her own new benchmark to compare the performance of this method, because the current benchmarks are not including it because it just has been developed and because it's often hard to extend and reproduce them. This redundancy in benchmarks also makes it really hard for the user to decide which tool to use, but also it's a very redundant work, so we lose a lot of time there. It's also hard because the conclusions of these benchmarks are different because they use different data sets and maybe make different decisions when evaluating their methods, so deciding which metric to they care most about and so on. So our idea, how we want to approach this challenge, is basically using continuous benchmarking. And this idea is not new in general, but this is the approach we have come up with now. So here we envision this continuous benchmarking and community benchmarking to consist of a lot of different modules. So different data modules, different method modules, and metric modules that can be basically generated by a benchmarker or just the method developers. So if you develop the new method, you could just commit a new module here, while that would extend the existing methods. And all these modules are then connected using the Renko platform, and I will explain you later what this is, and automatically updated using continuous integration and development. And also the results will be automatically updated, and we envision something that is interactive, so would also take care of the different decisions different benchmarker or different analysis want to do. So if someone prefers a certain metric or cares about a certain data set, he or she could basically weight this data set more than other, or have some, So this would make it easier for the analysis to face an individual decision instead of one overall summary. So we started to develop this platform by making a prototype or generating a prototype. And this prototype is on single-cell batch correction methods. So there we have different data sets and data processing modules. And just for you to understand that single-cell batch correction methods are basically, if you have different data sets like here that consist of different batches, like here, shown by different colors, and each dot in these t-SNE plots are different cells. You see that after correction with the batch correction method, these cells cluster no longer by batch, but by hopefully biological variants. And that's what these tools do. And we have two data sets there and one method called MNM. And then different metrics to score these corrections, evaluate these corrections, how well they are mixed, and how much of the biological signal has been retained. And this can then be explored by a better Shiny app that also has been developed in our team, which is an app to weight different metrics to your needs, and that will then accordingly fit the results and show you an updated ranking according to your own weights. So for this we use Renko, which is an open source collaborative platform that basically is based on a knowledge graph that will store all or will basically save all connections between data sets, inputs, outputs, and what has been done in between. So it will basically have an automatic provenance tracking for all what you do when you write. And it enables, the nice thing is that it enables you to write workflows that can be then connected using in different modules that can then be connected via the knowledge graph. So basically here, one data set would be one workflow. At the same time, Renko provides version data sets, so we can store results and input data there, and the connection, and track these connections. And it also enables interactive computing, so it's cloud-based computing and can be used via the browser, but also from command line interface, whatever people prefer. And of course, version code and an own container per method, which is a very nice setup, so that it's easy to work within different Docker environments for different methods, and to make sure that those methods work, even though they use different versions of whatever language. Also, Renko is independent of whatever software language you want to use, or bioinformatic language you want to use.